Today's work is going to be the reverse of what we have done in the first two sections. So in the first two sections, we were given the z-score and we were calculating the area underneath the curve. Now we're going to be given the area underneath the curve and we want to see what the z-score is. So we want to use the standard normal table to find the z-score that corresponds to the given percentile. Percentile is 80, meaning 80%. So the area underneath the curve is 0.8000. We want the area from the far left all the way up to here, and therefore we're going to calculate the z-score. Using my table and looking within the body, I see 0.7995 and 0.8023. 0.8000 is neither one, but it's closer to this. So the z-score corresponding to that is 0.84. So the z-score corresponding to 80% is 0.84. For the next problem, we're asked to find the z-score shown on the graph. We want the z-score corresponding to the right tail. Well, to find the area, we need to do that. We can find the area to the left of that by subtracting 0.0166 from 1 to give us 0.9834. And the reason we're doing that is, remember, the z-scores are always given for the area from the far left all the way up to the z-score. Since we want everything to the right, we have to subtract this area from the total area to come up with the white area. The z-score corresponding to that area is 2.13. For our next problem, we're asked to calculate the z-score between these z-scores for the area that's between the two z-scores. And I'm going to use my approach. There are a couple ways of handling this. I want to find the area of the two tails, the white spot. So I'm going to take and double the area shown, take that away from 1. That's going to give me the area of both tails. If I divide that by 2, that gives me the area of either tail. So 0.0222 is the area of either tail. Now, if I want the total area to the area on the left, from the left, all the way up to the z on the right, far left, all the way up to here. That is nothing. I'm going to add up those three areas, 0.0222, 0.4778, 0.4778. That gives me 0.9778. The z-score corresponding to that is 2.01. That's this z-score. Because I know this bell-shaped normal curve is symmetrical, the other z-score is going to be the same, but negative 2.01. For our last problem, we're going to have a survey of women. Their mean height was 65.4. Standard deviation is 2.75. What height represents the 98th percentile? Well, 98th percentile represents the area of 0.9800. The z-score corresponding to that area is 2.06. We're going to use the conversion formula that we have been using, but in reverse order. We want to calculate or solve it for the x. X is equal to mu plus z sigma. Plugging in a mu of 65.4, plugging in the z-score of 2.06, and the standard deviation of 2.75, and calculating, we're coming up with 71.065. Rounded to 2 decimal places, be 71.07 inches would represent the height of women in the 98th percentile. Part B says what height represents the first quartile. First quartile area represents 25% of the graph, or 0.2500, with a z-score of negative 0.675 from the tables. Plugging all data values into the formula for x, mu 65.4, z of negative 0.675, sigma of 2.75 and calculating, I'm getting a rounded answer to 2 decimal places of 63.54 inches.